enjoy some nice chat at the social event later. Now we start the last slot where we basically try to aggregate some. Sorry.
There's three more, right?
Yeah, there's
Including
four
this one.
presentations.
Okay.
Four
Oh, last
presentations.
slot. Okay.
No, last slot. Sorry, yeah. So last group of talks where I try to aggregate, let's say, the more client-side oriented aspects of WebRTC, which is an aspect that is usually a bit overlooked, but it's actually incredibly important because no matter what you do on the server side, most of the times you have to be aware of many things to actually implement client-side accordingly, or whether it's desktop, mobile, or anything else. And the first talk now will be done by Dr. Alex Gouaillard. He's one of the co-founders of CoSMo Software, a company based in Singapore. He's one of the greatest experts in the WebRTC community, so really doesn't need any introduction. And we worked a lot also together on many things, many different approaches to do the client side for Janus applications. So this will be his presentation. Let's welcome him with a large applause. Thanks.
Thanks, Lorenzo, for the very kind introduction. I will start with a word of warning. This is a pineapple-free presentation. Absolutely no pineapple has been used during the making of this presentation, and no pizza was tortured or coerced to have an indecent or unnatural relationship with a pineapple. Also, this is a voice over IP-free presentation, so the words Gamalio, Free Switch, and Asterisk will have, for the first time today, no part in this presentation. So if it hurts your feeling or your beliefs, c'est la vie. Finally! You were waiting for someone to say that, right? We are CoSMo. We rooted in academic research and R&D, a little bit like Mitico, and that's the reason why we work so well together. I'll go there. We used to cure cancer doing machine learning and artificial intelligence when it was not fun yet. And then WebRTC came along, and it was so much funnier. We're based in Singapore. We have people in Manila, France, Madrid, and Los Angeles. We believe strongly in open source, again, thanks to our root, and publishing results in peer-reviewed papers instead of doing marketing, claiming things that we don't have. So that's why sometimes if you read my blog, you'll see me ranting about marketing. There's a reason for that. Open source is a gift economy. You usually give more than you get. You have to accept that from the beginning. This is okay. Our contribution is mainly to the standard committee and to testing of the open source software. So we participate actively in W3C, IETF, IMTC when it was still around for testing, and our media for the new AV1 codec. And you're going to see a little bit of that in the slides because it all contributes to having a good ecosystem for the client-side implementation that people can build on top of with. We love C++ WebRTC, not JavaScript. C, assembly, codec, and testing, which makes us very, very popular because nobody else wants to do that, right? Most of the people want to have fun on the server side, or they want to do architecture, they want to do load balancing, they want to do a dynamic website and whatever. And as soon as it's like, what? I have to go native, really? Do I really have to go native? And then you got all people trying to kind of use a lot kind of things. We implemented testing tools for WebRTC was the goal, but it can be used for any kind of communication that involves two things talking. So it can be about chat, it can be about anything. For those interested, there will be a tutorial Wednesday morning, so I'll shut up there. A no-code fuzzing. So we weaponized Firefox and Chrome, modified version of Firefox and Chrome. So you can run your web application in it, and then Chrome and Firefox will do fuzzing of the media for you to attack your media server. So that way, even if you don't understand anything about fuzzing, even if it's too complicated for you, yeah, there's nothing to do. Take your modified version of Firefox and Chrome, run your web app in it, and usually within 1 second, it's going to crash unless you Jitsi and the Java virtual machine is saving you. End-to-end encryption, we implemented it with all of the open source WebRTC SFU vendors here, Jitsi, and so on and so forth. Right now, and this will be new for almost all of you, we're working on open sourcing H.265 hardware acceleration in WebRTC. So that's an ongoing project with Intel and Apple. Intel has the code, Apple wants it. They support H.265 in hardware in all the iPhone since 6S, so it looks like it's going to happen. At ComCon UK, the other conference you should be in Europe every year, we showed a few months back the first implementation of real-time AV1 encoding on a MacBook Pro. And we're speaking right now with the AO Media board to be able to open source the implementation. AV1 as a codec has been out for 2 years, but AV1 in WebRTC with the RTP payload spec is not, right? And that's what we're working on within the AO Media, but the spec itself is only as good as the open source implementation. So we're trying to tell AO Media, let's have an open source implementation as a deliverable, and then everybody will be able to use it out of the door. And finally, there is a lot of work going on quick. We have an implementation that is almost finished right now. We're speaking with different people, whether we put it out or not. It's very controversial at the IETF, so we're being very careful, but this is coming as well. We do other commercial stuff because we need to pay the bill. Those are less fun, but equally difficult, and they comes with an added dollar, so I won't go there today. We also help people adopting open source technology. Most of the time, the question that comes is, which one is the best media server? And they stop the question there, which is impossible to answer to, since every media server is pretty much suited to a specific use case or one place in the chain. So we did some blog post and scientific peer review paper with different quality of writing on comparison of the WebRTC SFU for the video conference use case, for example. Not only did he help people to make a choice, but during the writing, we find maybe 10 bugs in every SFU implementation, so everybody was happy to participate. For the IETF, we do what is on the left, which is a compliance report of all the SFU vendors compared to the specification, so people know where they stand with respect to the latest specification, whether they want to act on it or not. Right? Sometimes being bleeding edge means bleeding. Right, so not everybody wants to do that. We run the WebRTC test for all the browser vendors on a daily basis, so we know a little bit about the API on JavaScript as well. So this is, for example, the test from Thursday last week, since the technical plenary meeting of W3C was in Japan last week, and I presented those. And you can see there is still a little bit of work to do, but it's getting much better. That's the result, again, of the Kite tool that you can learn to use on Wednesday if you want. It's open source and it's free. So I'm not selling you anything here, just giving you more capacity to test your system against. It looks a little bit like that for people that just want to focus on the problem. You end up with everything down to the copy of the console log, so it's pretty useful. We have our own media server. We announced at ComCon UK last year, the other conference where you should be in Europe. But we still love Janus. Now, again, each of the media server is made for a specific use case. And we love Janus, especially in 2 use cases. When you go for IoT, the fact that it's written in C and scaled down to run on a Raspberry Pi is absolutely fabulous. Good job, guys. And when we want to connect to our TSP camera or some of those IP cameras, GStreamer, some kind of legacy support in the voice over IP word, we haven't thought anything better, and it doesn't make sense for us to try to copy it, right? The fact that the Janus team is participating to IETF, is publishing, so we're publishing together and so on, is all but a bonus on top of the fantastic code base. When you end up in WebRTC, you end up doing a lot of things. There is Turn, there is signaling and media server. Then you want some time to have a platform as a service and to run it and operate it. And then eventually you want to test all of that. Not everything is doable by oneself, so we team up. Midus, Janus, Jitsi, I should have Media Soup there in Aki. Promise next time it will be there because we're working with you too, so you deserve the credit. For the operation, running a platform and developing code is not the same, so we have different partners. And for testing, we develop Kite with Google. But eventually, that gives us all the map, because at one point or another, when you're a consulting company, you have a client that is going to come here and poke you on one side and say, okay, how do we do that? And that's the reason why we're here today. We have a lot of clients that come to us or to Mitico with a use case that we cannot each separately answer, and in which case we team up. And usually this is server side for Mitico and client side for CoSMo. So we created the WebRTC A team. I love that text, but I'm not going to read it. We provided a lot of code back. Well, we provided a little bit of code back to Mitico, specifically on the latest codec end-to-end encryption and support for the latest compliance specification for multi-stream. So I think Lorenzo did a good job back then. And we did a WebRTC Rockstar Asian tour where we all look like the men in black, except Lorenzo, who actually is a rockstar. Okay, so there is more to WebRTC than P2P, and there is more to WebRTC than the media server. So people start with a little proof of concept with one client app, usually a web app running in Chrome, and a single server. Life is good, you're done in one day, and then the real life starts, right? If you want a complete infrastructure, then you start adding on top of that load balancing, auto scaling. You're not limiting yourself to a web app anymore, or you want it to run on 5 different browsers, including mobile browsers, because God knows people like the iPhone. You need metrics, you need the turn, stern, iServers, and so on. If you want to make people pay for that, then you have authentication, tenant, payment, recording, whatever. And it's not because you wrote it that it's working. If it's not tested, it's broken. So you need to get all the tooling that goes with that, the unit testing for each of the parts, interoperability testing, different client type, and so on and so forth. So today, we're going to speak about what is in blue, the client side, and the unit testing that goes with it. And Wednesday, I'm going to speak a little bit more about system level, interoperability, load testing. First, LibWebRTC is super easy. That's why people use GStreamer and anything else they can find, right? So let's take an example. There is only, let's say, 10 classes to touch to add AV1 support or H.265, whatever new codec you want. You have to modify the green and the red one, and you have to add the blue one in the list of the codec you can support. Right, that looks easy. Right. That's just the encoding. Then there is the decoding, and then there is the packaging and the depackaging. So that becomes that little small selection on the right-hand side. Oh, wait. We're speaking about WebRTC. We're not lucky we don't have Janus that tells us, forget about SRTP, just RTP forward, and you're done. So if you just RTP forward, you're good, but you don't. So you have to add the signaling, GSEP, the encryption, the I support, and so on and so forth. So what you have here on the right is the yet unseen full map of all the classes there is in the WebRTC. Even Google doesn't have that. It took us 6 months to get that right. So it's not easy. So there's not a lot of people that go there. So what do people do? They take the code, they compile it, and when they manage to compile it in a way, that's it. Don't ask them to modify anything, because something as simple as adding support for a codec with a codec library existing, like our NVIDIA hardware acceleration, leads to this. So you can imagine when you want to do something more complex. If you dare, come to me at the break and let's speak about adding a new bandwidth estimation or congestion control to that. It's going to be fun. So as a product maintainer, I want to stay away from that. I do not want to deal with fetching, building, or validating LibWebRTC. I want a pre-compiled, pre-tested, pre-validated, importable, relocatable, rebase easily package, right? So for a very long time, the first 6 months, what CoSMo was doing as a company is to sell the package, and God knows there were a lot of different possibilities, depending on the compiler you want, whether it's your 32 bits for an Internet Explorer plugin or 64-bit or whatever. It was absolutely crazy, but we solved that problem. And we solved that problem because we managed to work with Google or around Google to find a way to test at the same level and they were testing the code, right? So we have unit testing. So this is my dashboard. On the top are all the projects, all the library and the final client. On the bottom are all my daily build bots that I own and operate for the team. This is on a single day, all the builds that are going on. So I have different machine, and then I have all the variation of LibWebRTC version, operating system version, different compiler, and so on and so forth. That was the day when I tried to use for the first time MSVC 2019. That was not a good day, right? So the first left with the red on top is the configuration. If you're stuck there, you're in a deep ocean. Once the configuration worked, the build can still fail. That's the second part. So, okay, I solve the configuration, I go into the build. And when the build failed, then I have all the unit tests. So if the unit test looks like that, so we reproduce exactly the same unit test that Google does on their own infrastructure, including the sharding, to make sure that you get exactly the same thing that Chrome does. Don't ask us how we did that. You have on the left the list of all the tests with all the shard, and one shard, for example, this one, can be 277 tests. So actually, LibWebRTC is a pretty well-tested library. It's more than 90% coverage. If you manage to find the way Google run the test, which is not documented, right? So, or just come to us, we'll get you a package. You can use it blindly because after all, that's what you want. And that's for the unmodified one. So how do we bring value to Mitico, for example? We have a modified version of LibWebRTC. You're a telco vendor. You want to use G729 because it's supposed to be free nowadays. It's in the public domain. And if you have that in your native clients, then you don't have to transcode in your gateway, right? So it makes your infrastructure easier. Well, we have a modified version of LibWebRTC with that additional codec specifically for the telco operator that asks for it. I want end-to-end encryption like Duo does, but that's a client-side thing. It's not so much of a server-side thing. We got you covered. I want this, this, and that. Well, depending on how much you're ready to pay, we got you covered too. So how does that work? You take a server. If the server has a plugin architecture like the Janus server, you choose your plugin. So I put SFU, but in this case, it means VideoRoom, right? Which implements an SFU logic. We're going to provide you LibWebRTC, which is the media stack. You have to come with the signaling, or we can help you develop the signaling together. And then you can implement that into your application. So we did a few variations of that. We have an Electron desktop client, we have a Qt desktop and mobile client, and we have OBS Studio, right? So OBS Studio, for those who don't know, is the #1 software for people that want to broadcast their Minecraft session on YouTube because you know they're going to get a millionaire. It allows you to very, very easily compose the scene and the different input. So you can have a game acquisition card connected to your switch or whatever your poison is to bring it in. You can have your camera, and you can then combine your camera as a sub part of the scene, and it does that very fast and very efficiently. But OBS at best can only output Flash, which is what YouTube, Twitch, Video Motion, and everybody uses today, but you can do better than Flash, right? It's called WebRTC. So we put LibWebRTC in OBS, 4 days the first time, only Windows. And now I can use the same graphical interface, the #1 using the word. Yeah, I can use the same setting. I have my special effect, my fake mustache, you know, everything. And stream directly to many WebRTC services or servers, including Janus. The code GPL is open source and free. Go take a look. So if you look at everything that is possible, this is what you need to do. On the top left-hand corner, you have basically the 3 types of LibWebRTC build you want, depending on whether you're on desktop or on mobile. On the bottom, you have the custom build that CoSMo provided, watermarking, OpenSSL instead of boring SSL, end-to-end encryption, additional codec. You can put AV1 on the list now there. This is an old slide. And then you have all kind of application. And that's the map for version 69 of WebRTC. We had Flutter, IoT, even for Samsung TV, Tizen OS, and things like that, some esoteric SDKs. You're fine. You're covered. And you can do that with Meduse, or Jitsi, or Janus, or Millicast, which is our platform. That means even people that want to use another SFU than ours, we're okay. We can provide you with the SDK. We have not only the media stack, but also the signaling stack for you. So the thing is, people come at it all from different angles. Some people are web first. So they're going to start with a web app. They're going to start with Chrome. And then they're going to have their web app run in a browser, either desktop or mobile, to eventually provide the media stack. So the browser provides the media stack. The signaling stack is implemented in JavaScript. And you have the logic of the application that is also in JavaScript, CSS, HTML, and so on and so forth. First thing they want to do once this works is to extend to more browser. Well, good luck. Some people decide to stop at Chrome. A little bit more next slide. The situation is getting better. But for people that have tried at least 1 year ago, that was difficult even to support Chrome and Firefox, and let's not speak about Safari. Then once they've done that, people say, okay, I'd like to go mobile or I'd like to go desktop, but I don't want to go full mobile, because my team doesn't like C++ assembly, right? So I'd like to be able to reuse as much as the team I have, the skill set I have in the existing code. So I'm going to try to find framework to go around that. So you're going to have a lot of very good talk from Dan on React Native. I saw them at ComCom UK, the other conference you want to be in Europe. You really owe me a beer, man. And it's pretty good. Or the other way is Electron, right? So desktop and mobile. This is today the most popular way to extend your existing web app to a pseudo-native app or half-native app while reusing most of the code. So what's the situation in a browser? So again, this is the official web platform test results from last year on top and this year on the bottom, right? So this is the way you read it. You have 0, 1, 2, and 4 out of 4. It means how many browsers pass this test without failing. Last year, we have not a single test that was working across the 4 major browsers. In the meantime, Microsoft dropped Edge and used Chromium base, which helped a little bit, but nonetheless, if you look at the 4.4, so the right-hand column, which is really the goal, you want everything to be there, you can see that we, on the main WebRTC spec, are at 700 passing tests across the 4 browsers out of 1,600. So 700 out of 1,600, up from 0 last year, right? So that's pretty good. If you add on top of that the 300 tests that pass on 3 main browsers, you're really good. That does not represent mobile though, but that shows you the big improvement in the WebRTC situation between last year and this year. Some people say web app is old, I'm mobile first, right? So they're going to start there and say, okay, what are my options to start with WebRTC client side on mobile? Well, you have 2 examples provided by the libWebRTC code that most of the people copy and start from, AppRTC Mobile and AppRTC Mobile. So one is with an Objective-C framework, and the other one is with a Java framework. Not a lot of people know it, but since 1 year ago, they actually extended the iOS one to work on macOS. So now you can use that AppRTC app. You have the web app, you have the iOS app, the macOS app, the Android app. So it's a good base to start actually something if we do not have anything else. The big difference here with the web is that you need to provide your own media stack. So the browser was providing you with libWebRTC internally. You just use the API. Now you need to find a way to provide that stack. So some people will use GStreamer. We go for libWebRTC. Both are equally good. But you have that hardcore red spot in the middle, which is usually the place where the difficulty comes. The second problem is that there is no real way to reuse any code across. So in that example, the red is the core library. The green will be the SDK. So you can see on the right, we had the Janus signaling SDK, Minicast signaling SDK, Evercast, all of those to eventually have the application on the outside mostring. It's very difficult, unlike precedently, to reuse some signaling code or UI code or UX code across the application. What we really want, we had a dream. We wanted to start with a web app because it's simple and we can iterate on it easily. We want to be able to reuse the JavaScript signaling API and logic to remove duplication of the code if we can. Except for JavaScript, we do not want any binding, right? We don't want to duplicate. We want to have the minimum programming language possible. So we would like a single source code, if possible, assembly C++, since libWebRTC or GStreamer is written in that, for mobile and for native. Professional cross-platform UI, professional cross-platform build, test, and report tools. And thanks someone, God, Buddha, whatever works for you, Qt came and CMake. So Qt is fantastic, and I'm going to show you an example after why it's fantastic, but the idea is you can reuse the code for mobile, desktop, all across, right? dreams do come true. It just takes more sweat than you would think or at first, and you would really want to have. But the biggest problem with Qt, or what was remaining once you decide to use Qt, was to align the build system between GStreamer or LibWebRTC and Qt Creator, to align the threading model and the memory model, the garbage collection. And some of the JavaScript reuse was also a little bit difficult. Qt is not friendly with the standard C++ strings. And so when you try to pass the strings from your offer answer SDP through the Qt API, then you have all kind of hoops to go through and so on. LibWebRTC does not provide capturer or renderer, right? So you need to provide a Qt renderer that understands the image formats that WebRTC is going to output and put it on the screen fast enough. And you also need to provide desktop and application capture. The device capture connecting to the camera is pretty much supported. The desktop is not. Finally, Janus is at the bleeding edge, which means you're going to bleed. And that's one case where we bled. Janus adds a WebSocket subprotocol for security. So you need to declare, I think it's Janus, right? The name of the WebSocket subprotocol you use? Right. Unfortunately, Qt WebSocket implementation does not support subprotocols, so we had to use another WebSocket in C++. Well, there are 4 or 5 different libraries, so this is not a problem, but just know that you will not be able to use Qt WebSocket out of the box. So what do you get with that? And that's my last slide. So you see the pure web on the bottom left down corner, right? And with Qt, you have Qt WebRTC SDK, Qt WebRTC SDK, whether it's mobile and native. The only difference is that it's compiled for ARM or Intel CPUs. And then you have binding into QML, which is another name for JavaScript, which allow you to reuse your web JavaScript SDK for the signaling, right? So by using Qt, you can have the same application logic and code for mobile or native, whether your signaling is written in C++ or in JavaScript. So you have everything we listed before. So it simplified the number of applications we had to support internally for all our different clients by 4. And since then, we've been reusing that a lot. And that's it.
Thanks. Amazing presentation as usual. So, do we have any question for Dr. Alex?
So about the on-frame callback, if you're using the libWebRTC, many people probably know that QML is usually hardware accelerated by using OpenGL. So did you use here any sharing of the OpenGL contexts or something like that to have some, to directly upload video frames to the GPU, or are you going where the Q main thread and the main event loop?
So, okay, first, there is an ambiguity on hardware accelerated. What you mean is display, right? For the
yes.
Not for the encoding or decoding, right?
Yes, I'm talking about the rendering of the GUI and the presenting of the final presenting. I'm not talking about accelerated encoding or decoding.
Right, okay. So for the display, we use the OpenGL display from Qt directly. We couldn't optimize more because you need to make one copy at one time. The output of libWebRTC is already not in the GPU anymore, even if all the decoding was in the GPU. So we didn't, that would be a huge modification. We didn't go there, that's number one, because number two, the rendering is already fast enough, so we didn't have to optimize. Right?
Okay.
So if it's not broken, don't fix it.
Okay, thank you.
Thanks. Let's give Alex another round of applause. Thank you.